We welcome you at the Technical Forum at the Group Exhibit Hydrogen and Fuel Cells 2013. Please have a seat, have a free drink. You are invited to listen to the next presentation and ask some questions at the end. Come and enjoy here with us the next presentation. It's about fuel cells for materials handling vehicles from ITM Power, from the Business Development Manager, Steve Jones.
Thank you. Thank you. Okay, so I'm here today to talk about fuel cells and materials handling applications, and also I'll touch a bit later on actually fueling those vehicles from on-site hydrogen production. So, a snapshot of the materials handling market. So, the market as it stands at the moment is a very demanding market. The grocery and logistics companies operate 2 to 3 shifts a day, 24/7, 365 days a year. So the demand on these vehicles is very high. Big focus on productivity and reliability of the fleet, obviously. Shipping groceries and other things around the country simply can't afford any reliability issues with the plant. A lot of these companies operate in indoor warehouses, so those indoor warehouses dictate that the vehicles that are used need to be zero emissions. So, you know, a lot of these companies, diesel, LPG is just not an option for these guys. So for that reason, at the moment, the market is heavily dependent on battery technologies. Batteries are very good at what they do. A few problems with batteries are that they actually require to be changed out. So if you're operating a vehicle on 3 shifts, 24 hours a day, a single battery will only last 6 to 8 hours. So at that point in time, the battery needs to be changed out for a new battery, and they have big battery charging stations where they actually swap in and out those batteries. And actually, within large logistics warehouses, 70% of all accidents are associated with the manual handling of taking the batteries out and putting the new batteries back into those vehicles. So for that reason, if you've got a fleet of 100 vehicles, say, you will have on site between 150 and 200 batteries, because you need to keep them charged so that when they're swapping the batteries out, there's always a freshly charged battery waiting. So modern materials handling vehicles, quite a diverse fleet, split up broadly speaking into 3 classes: class 1, 2 and 3. Class 1 is the counterbalance sit down type forklifts. Class 2 are the large reach trucks for the high level storage, and then class 3 are these small ride on sort of pallet trucks, if you like, for low level loading and order picking. And in the larger fleets, the groceries and the logistics fleets, it's actually the class 3 vehicles that dominate the fleet in terms of physical number of vehicles. And when you drill down into the details of actually, you know, what does it cost to run one of these fleets, actually sort of 80 to 90% of the total cost of ownership of the fleet is down to operator labour, particularly in Europe, where labour rates are relatively high. So obviously that's a key factor. So a lot of what the managers of these facilities do is trying to keep those operators and the drivers of the vehicles as productive as possible. And obviously the time that they spend changing batteries is downtime, it's non-productive time. So they want to try and minimize that. So a couple of slides on the differences between a fuel cell materials handling vehicle and a battery vehicle. So first thing to say is that there are fuel cell solutions available for all classes of forklift trucks as a total fleet conversion solution. The fuel cells themselves are identical in terms of size and weight of the batteries. So this picture here, on the right hand side is the battery pack, on the left hand side is the fuel cell. So it's literally a slide in, slide out conversion. Particularly with the counterbalance, the larger systems, the weight of that fuel cell is critical, because the weight of the battery is used within the truck as counterbalance for whatever they're lifting and moving around. So actually, what you find is that the fuel cell manufacturers have to add a lot of ballast weight to the system in order to make it the same as the battery that it replaces. In terms of lifetime, the guys that are making the fuel cells for these pieces of equipment predicting 10 years of usable life of a fuel cell system versus 3 years at a push for a battery system before it needs to be replaced. The big factor and the big cost saving in all of this is actually the time that it takes to get a new store of energy on board that vehicle. So a battery can take 5, 7, 10 minutes to actually change a battery out, whereas refueling it with some more hydrogen via a nozzle can take sort of 90 seconds. So your operator is spending a lot less time doing non-productive work, and he can be back doing the job that he's supposed to be doing very quickly. And when you've got a fleet of 100 vehicles, that time soon adds up, and over a year it adds up to quite a significant amount of money for the operator. Obviously, at the same time as reducing the time that you take to change the battery, you eliminate the manual handling activities around swapping batteries, because you're simply recharging them with hydrogen. You're also reducing the amount of accidents and staff injury based around accidents and claims for staff members becoming injured at work and all these things that we have today. And in the US, this technology is already commonplace in a lot of big companies. So your Walmarts, your Cisco's, your BMWs are already operating 100% hydrogen-powered forklift truck fleets. With the elimination of the manual handling of the batteries, obviously you also eliminate the charging station. You know, these things are pretty big. They can be 10 meters long by 5 meters wide. So they physically take up floor space in your facility. So that frees up floor space for more stock, for more for value-adding purposes. The other benefit for a fuel cell is that it performs effectively like a 100% charged battery all the time. So one of the problems that you see with batteries in hour 1 of the shift, the battery's fully charged, you can do a lot of work. In hour 8 of the shift, when the battery is becoming discharged, the battery will actually do less work, so it becomes a less productive piece of equipment. Whereas a fuel cell effectively acts like a 100% state of charge all the time, regardless of how much hydrogen you've got in the tank. So one vehicle can do more work in a day. So what that means is that you can reduce the amount of trucks within your fleet. So if you have 100 trucks operating on batteries, you could do the same amount of work with maybe 90 fuel cell trucks. So you eliminate 10 trucks, but as you eliminate those 10 trucks, what you also do is you eliminate 3 to 4 members of staff per truck, because you're operating on 3 shifts per day. So the big cost savings are seen in the operational cost of removing vehicles, but more importantly, removing the labor rates associated with those vehicles. So the vehicles themselves have obviously got benefits. Now what I'm going to talk about is how you get hydrogen into those vehicles. And my company, ITM Power, focuses on producing hydrogen energy systems for on-site generation of hydrogen via electrolysis. So it's about using renewable energy, splitting water into hydrogen and oxygen, and then using that hydrogen to fuel vehicles. So a trial that we did in the UK last year, we did a trial with a company called Marks and Spencer's. They're a large UK retailer of food and domestic goods, clothing, those kinds of things. It's the first trial of its kind in the UK. And what it entailed was there were 4 fuel cell vehicles in total, 3 small Class 3 pallet trucks and a single Class 2 reach truck vehicle. And we also deployed our mobile on-site hydrogen refueling station on site. So we set it up in their car park. We ran the vehicles for a period of 6 weeks on a 24/7 basis. The fuel was made on-site from electricity. And as I said before, you know, this market is rapidly growing, particularly in America, and Europe's following suit. So the main players involved in the trial, Marks and Spencer's was the actual owner. It's a company called Wincanton, they were actually the subcontracted operator of the site. Lift trucks were Crown lift trucks, and the fuel cells were a company called Infinitium, which I'll talk about in a little bit later. So results from the trial, we saw productivity increases for the fuel cell trucks versus the battery trucks that they replaced. The actual staff and the buy-in from the people that were actually using these trucks was very positive. The staff preferred using the fuel cell vehicles because they didn't have to spend any time recharging them. They performed at a solid level all day long. And the refueling process is very simple. Touchscreen interface. You basically put in your operator key, press go, and it's an automated filling profile. And actually, we saw towards the end of the 6 weeks is that the staff members were actually coming in early to make sure that they were able to use one of the fuel cell vehicles for their shift as opposed to one of the battery vehicles. And when you drill down into the detail of costings and all that kind of, which is obviously proprietary information to the trial, so I can't share that with you today, but there was a good return on investment seen on the proposed conversion of that fleet. So the fuel cell systems themselves, this is an example of the reach truck. So this is the loading bay where the battery normally sits. So you roll the battery out, and this is the fuel cell system being slotted back in. So it's a simple swap in, swap out. As far as the truck's concerned, it's just got a fully charged battery. ITM have become an exclusive European distributor for a company called Infinitium Fuel Cell Systems, who are a US-based fuel cell organization. It's a non-exclusive contract, so that allows us to be able to work with whoever makes hydrogen fuel cells for materials handling vehicles, and enables us to deploy our refueling solutions with anybody. But we can offer a full turnkey package through Infinitium, fuel cells and refueling infrastructure. So this is a picture of a fully integrated refueling station. This one's actually got the dispenser mounted on the outside of the container unit. That dispenser could quite easily be a pedestal type dispenser that was actually inside the factory rather than external like this one. And the kind of holy grail of all this is to use on-site generation to provide a 000 fuel. So that means there's zero carbon associated with the generation of the fuel, because the generation of the fuel is powered from renewable energies. And distribution centers and large logistics warehouses are prime examples of areas that have got very large roof spaces. And with current incentives of PV integration, you know, they've got vast roofs and they can generate a lot of power from PV, which can be used to make the hydrogen. So there's no carbon associated with the generation of the hydrogen. There's no carbon associated with the transportation of the hydrogen, because you don't have to drive it to site on a diesel truck, because you're generating it at the point of use. And obviously the vehicles themselves have zero emissions. So so the kind of 000 fuel is the ideal scenario, is where we want to go to. The system is modular, the refueling system is modular, and what this slide, I know it's not very easy to see, but what it shows is that you can modularize the refueling solution. So at the start, you can maybe only have a small fleet of fuel cell vehicles while the customer is still testing out the technology, and you can have a small refueler. As that grows in the future, you just deploy more and more modules of electrolysis to increase the amount of hydrogen that you're producing on site. And also you can have a mix of hydrogen. You can have a mix of on-site generated hydrogen and delivered hydrogen. And the big benefit for this in this particular market is that a lot of logistics companies, and particularly grocery companies, see a big spike in their production levels at around the holiday period. So at Christmas and at Easter, they have a huge ramp up in production because people are buying more stuff at that period of time. So rather than spending the capex putting in a very large refueler to cope with those two peaks in the year, what you do is you size your on-site generation for the base load for the majority of the year, and then during those 2 months of peak demand, you can truck in some additional hydrogen just to cope with that extra demand, and that, you know, that makes the whole solution more cost effective. Compliance-wise, obviously there's a lot of compliance to go through for on-site hydrogen, and particularly indoor refueling for materials handling vehicles for hydrogen. So we're involved in ISO committees, SAE refueling protocol committees. All the products are CE marked and conform with all the relevant standards that they need to conform with. But you know, that's not an easy task. It's a long road to go down to achieve that. So really, our reference deal with Marks and Spencers has enabled us to start discussions with all of the top retailers within the UK, and that's expanded now to customers in Europe as well. We're also talking to customers in the US through our links with Infinitium as well. And the target markets really are logistics and outsourced distribution markets, as well as the grocery markets that we're already tapped into. So in summary, using fuel cells for materials handling solutions offers significant savings in operational costs for that fleet. The elimination of the battery swapping and the manual handling that goes on with that battery swapping, coupled with the short refill times of hydrogen versus the time that the operator would spend changing batteries, means that the operational costs and or the payback periods can be reduced. And actually making the hydrogen on site provides a route to a truly zero carbon solution. It also gives the customer that fuel independence, so they're not relying on people driving through their sites with compressed gas. They're not slave to if there's a traffic jam on the motorway or whatever. They're in control of their fuel provision. And also, this technology is available today. So there are companies in America that are already using it. There are companies in Europe that are looking to deploy it. So we're trying to position ourselves in the marketplace to provide both sort of sides of the coin, the fuel cells and the refueling solutions. So that's it. Answer any questions if you got them. Thank you.
Yeah. Thanks a lot for this interesting presentation, and like you said, Mr. Jones, now you have the opportunity to ask some questions, or do you have some remarks or comments? Yes?
Thank you. Your on-site hydrogen production system, are you producing it by yourself?
Yes. ITM Power manufactures. It's a containerized system. So they're all housed in metal shipping containers, and so they can be deployed rapidly. All you need is a flat surface, a power connection, and a water connection, and you can generate your hydrogen on site.
And it is produced by renewable energy, yes?
Correct.
Correct. By photovoltaic or such things, or what?
Sorry?
By photovoltaic or
yes.
what? Yes.
Yeah, or wind, or whatever's available. Whatever's available. Yeah. We've got customers as well that maybe have restrictions on their site or planning and permitting limitations to what they can do. So they're looking at renewable tariffs for their energy production. So although the energy is not being produced on site, it's being produced renewably somewhere else and fed through the grid. So it's a combination, really.
Thank you. He's first. I'm coming to you soon.
Morning, Steve. My name is Andrei Chulov. Hi, Safe. A question to you about that introduction project with Marks and Spencer, if you can elaborate. Is the refueling indoors?
The trial that we did was using our mobile refueler, so the actual refueler is bolted to the side of the container. So during the trial, the container was situated close to a roller door, so it was actually outside refueling, but it was 50 yards outside the door and then back in. But later on, looking later down the line, then obviously the refueling needs to come indoors. It needs to be on the shop floor, so that the time that they take between leaving their post, going to refuel and coming back to do work is minimized.
So how many refuelings have you done so far?
In total?
No, for that trial.
Oh, that trial? I don't know. There was 4 trucks being refueled 2 to 3 times a day for 6 weeks. Okay. So they were operating 24/7. So we're actually seeing that some of the smaller vehicles were taking between 12 to 16 hours before they needed to be refueled again. So just on a case-by-case basis.
Thank you.
Thank you very much. You've shown us the benefits of the operating costs, and even though you said that the cost information is proprietary, I think the basic decision is also dependent on the investment costs, the capex. And if you take an optimized generation plant with the photovoltaic or the percentage of the on-site power you need, you add the refueling station for that's what's on-site, plus that proportion which is brought in at peak. How does this compare with a normal battery station over the lifetime?
Sure. Okay, so what we saw is obviously it depends on sizes of fleets and how much you pay for electricity, and you know there's a few inputs to that equation. But generally speaking, with the trial that we did, we drilled into those costs, and what we saw is that the return on investment was a period of around about 5 years before you then got above the curve and we're starting to see the benefits. So it's a mindset change really for some of these companies, because it is quite heavily front-loaded in terms of capex, but the operational savings that you see down the line quite quickly turn themselves around and start making profit. But for a lot of these companies, it's changing the way that they finance their business, because they're used to outsourcing a lot of their costs. So it's an OPEX weighted solution, which is what they use today, versus a capex weighted solution, which is what we're offering. So that process can take a little bit of time, but the savings that you see when you're looking at a 5 to 10 year time span, you know, are quite significant.
Okay, so it is viable for a capex model.
Yeah. Yeah.
Thank you.
Yeah, no problem.
So, thank you. Are here any questions left? No. Okay. Thanks again for being here and to discuss with us. If there are any questions left, or you like to discuss with Mr. Jones in person, just follow him to the booth B60 here at the group exhibit, Hydrogen and Fuel Cells.
Yep.
Okay. Thank you very much.
Thank you.
So, in a few minutes we will start with the next presentation. The topic is testing and characterization of electrolysis and SOFC at the FCH Test Center of the Technical University of Denmark. Please being here, have a seat, have a free drink, just ask our hostesses, and join with us in the next presentation.